I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic we selected for discussion is Charpit's method. This video lecture includes Introduction to Charpit's method, problems based on Charpit's method. The Charpit method, which is used to find the complete integral of non-linear partial differential equations of first order. Non-linear, that is the degree which is not equal to 1. First order, dou z by dou x. This is first order. So, the first order partial differential equation, but this dou z by dou x, the degree is 1. We are going to concentrate non-linear, that is more than 1. Such type of partial differential equations to solve, we are going to use Charpit method. So the first problem is solve px plus qy equal to pq. So now the function which has the variables x, y, z, p, the notation it's nothing but dou z by dou x, q, dou z by dou y. Now what is given in the question px plus qy equal to pq? That we have written as px plus qy minus pq equal to 0. We named it as equation 1. Now, dou f by dou p, that is, f we have to do partially differentiation with respect to p. So, where the variable p is there in the equation, first we will search. Here and here. The second one we will neglect it because there is no p term at all. The variable p, it is not there. So the here and here, the variable, the p, it is there. So with respect to p, so it is 1. So 1 into x, x. Here also 1 into q, q. Already minus sign is there. So minus q. So dou f by dou p is completed. Next dou f by dou q. Here qy it is there. So the q, the differentiation is 1. 1 into y, y. More y, that is q with respect to q we are doing. Here it is there. So here the q, the differentiation is 1. So p into 1, p. Next, dou f by dou z. Complete our given equation. There is no z variable at all. So our result is 0. Next, dou f by dou x. Only the first term which has x variable. So with respect to x, the differentiation is 1. 1 into p, p. Next, dou f by dou y. The second term which has the variable y. So the y, the differentiation is 1. 1 into q, q. So we completed the partial differentiations. So the Charpit's auxiliary equations are, before that, this is the Charpit's auxiliary equation. To substitute here, we needed the terms, those terms only, just where I am putting the tick, These terms are required. So before in hand we got it, we obtained what is the result we obtained that we are going to substitute in these places. The first one is dou f by dou p. So here we got it x minus q. So minus of x minus q. The next one is dou f by dou q. That is minus of this y minus q is substituted. The next one is minus p, yes, dou f by dou p. That is x minus q. Here it is substituted. This minus sign, this minus sign. Here q, here also q. Dou f by dou q. That is this y minus p. It is substituted here. Next, dp by dou f by dou x. So dou f by dou x is p plus p dou f by dou z. But dou f by dou z is 0. So this place is vanished. Only the result is dp by p. The last one is dq by dou f by dou y. So dou f by dou y, we got it q, that we substituted, plus q dou f by dou z, that is 0. So this completely it is vanished. So after substituting the values what we obtained in the Charpit equation, totally 5 members we got it. 1, 2, 3, 4, 5. Among these 5 members, any member we can take, and we have to simplify. Our main aim is what is P and what is Q, the values to be expressed in terms of X and Y, that we have to obtain. That is only now our next the criteria, our goal, towards that we are going to move. For that, we are going to select these last 2 terms. That is, these 2 terms, if we take, our time will be saved. The problems, it won't come under more complicated. So it is very easy to do the integration also. So the last 2 terms we selected, we are doing integrating on both sides. Very simple one. So the integration symbol on both the sides, they are placed. So dp by p, the integral is log p. dq by q, the integral is log q, plus the constant we should add. But already the integrated one, they are in logarithmic form. So we are adding the constant log c1. So the next one is log p. Here the logarithmic formula is log a plus log b. Log a plus log b, it's nothing but log of ab. So that logarithmic formula, we will use it. So ours is q and c1. So we are getting log of qc1. Both the sides we will cancel log, and we obtained p equal to qc1. This we named it as equation 2. Now p by q equal to c1, we got it. Now solving the equations 1 and 2, so that is, we want to obtain what is p and what is q. So this is our first equation, that is our equation, and we did substitution in a Charpit's the formula. Afterwards, your relation we got it, p equal to qc1. Now we want the value of p and q expressing in terms of x and y. Now This is our equation 1. Just now what we obtained, that is P equal to QC1, we got it. So wherever in the equation P is there, we are going to substitute. Here 1, here 1. So the two places P is there, so we substituted 1, 2. Remaining, we didn't touch at all. As it is, they are written. Now, after substitution, we are noticing throughout Q is common. So Q we have taken out. So the remaining one, C1x, here Y, here is C1Q. This we are pushing to the next side. So C1x plus Y minus C1Q equal to 0. So C1x plus Y equal to C1Q, from which we will get it. So this is the result in the last step. So from which we obtained what is Q, that is C1x plus Y. We brought C1 to the left side. It has become Q equal to C1x plus Y by C1. Now, this is our first equation. Just now we obtained the value of Q. With that help, with the aid of that, we will find what is P. So now, this given question, 1, 2. So where I put the ticks, P is common. So we have taken P. Here the balance is X. Here the balance is Q. So P of X minus Q, that is we have taken the variable that P has common. This QY, it is written as it is. Next, P equal to minus QY. Just we brought the QY to the next side. So minus QY by X minus Q. So P is nothing but QY. Here this minus sign. Here my X minus Q is there. We have written minus of Q minus X. This minus minus cancelled. So finally we got it. P, the value as QY divided by Q minus X. So we obtained the P value as QY divided by Q minus X. Already we got it. What is Q? So the Q value we will substitute here. That is C1x plus Y by C1 of Y. Here we are substituting C1x plus Y divided by C1. This minus we are substituting here, minus X. So the next one is here, the numerator which is written as it is, whereas denominator we have taken the LCM, that is we did the cross multiplication. So C1x plus Y minus C1 into X, it has become C1x divided by C1. The next step is here C1 x plus y divided by C1 y. That is, this is completely our numerator. Just without any change we have written. Whereas the denominator part, these two are cancelled. So the leftover is y by C1. Just we are bringing up the reciprocal in a way we are writing C1 by y. This y getting cancelled, C1 getting cancelled. So the leftover is C1x plus y. So we obtained the value p as c1x plus y. So therefore p equal to c1x plus y. P value we obtained, Q value we obtained. P value is c1x plus y, Q value is c1x plus y by c1. That this is the steps for using this solving the problem. After finding the value of P and Q, we have to substitute in this format the formulation, that is d is equal to integral of P dx plus Q dy plus constant after doing the integration. Already C1 we introduced, so that's what here it is. C2 we have written. Now the P value what we obtained, that is C1xy of dx. Q place we substituted the Q value, that is C1x plus y divided by C1 dy plus constant. Now this one we have to do the integration with respect to x. That is C1 x, the integration is x square by 2, and y dx, y it is written as it is, dx integral is x. Next C1x by C1. C1 they are getting cancelled. X with respect to y we are doing, so xy. Here y is there, y by C1, so the C1 is written. Y dy, the integration is y square by 2, that's what it is here, plus C2. So this is the step just now we obtained. So more simplification, the middle xy plus xy, we can write it as 2xy, remaining there is no change at all. So which is the required solution for our given the formation of the differential equation, that is c1x square by 2 plus 2xy plus y square by 2c1 plus c2. So the next problem is solve z square equal to pqxy. The solution is, so the function given which has the variables x, y, z, p and q. So the function which is expressed in terms of these variables, and the given question just we have written such a way, z square minus pqxy equal to 0, and we named it as 1. So the equation is 1. Now dou f by dou p. So the dou f by dou p, here it is there. We have to do where the variable p is there. Only in this it is there. So the p. So the p, the differentiation is 1 into qxy. The minus as it is we are writing. So the next one is dou f by dou q. That is q, the differentiation is 1 into the remaining, that is minus p xy. The next is dou f by dou z, that is z square. The differentiation is 2z. Next dou f by dou x. Only in this here the variable x is there. So x differentiation is 1 into pqy is pqy. Here the minus sign is there, that it is written here. So the next one is dou f by dou y. Again, our question only here only why it is there. Why differentiation is 1 into minus pqx. So minus pqx. So these are the terms, the values are needed to substitute in our formula of Charpit's method. So this is the Charpit formula. So the Charpit formula which is written here. So these are the terms already just now we discussed. How we obtained also we discussed. Now we will start the substitution. So the first one is dx by minus dou f by dou p. So here we are going to substitute in this place this one. So it is substituted where I am circling. The next one is minus dou f by dou q. So minus. So here we substituted this one. Next, dz by minus p dou f by dou p. That is, this we are substituted. Next, minus q dou f by dou q. This we have to substitute. Here we substituted. Equal to our, this is first member, second member, third member. Now we are in fourth member. That is dp by dou f by dou x. Here is there minus pqy. So it is here written. Next, plus p into dou f by dou z. Our dou f by dou z is 2z. So 2z p. The last member, that is dq, dou f by dou y. We are circling. So that is here substituted. Plus q. Here plus q. Dou f by dou z. That is 2z. We substituted here. So all the values what we obtained regarding p, q, x, y, z partially, everything we substituted in our Charpit formula. So this is the part of the substitution. Some simplifications regarding signs where it is needed, we have done it. That is this minus minus, plus we made it. Here also minus minus, plus these also we have taken the minus plus here also. So the changes here regarding signs, here there is no change at all. As it is, we have written the fourth and fifth member. Now we got it 5 members. Any member we can take any simplification. Finally, we have to obtain what is the value of p and q. So we are going to take first and third member. That is first member and third member. These two members we are taking. So we have taken. The simplifications what we are going to do. The first member up and down we are going to multiply by p, and this third member up and down we are going to multiply by x. So we multiplied here pp, whereas the third member x to be multiplied x. Here also x is multiplied, here also x is multiplied. Why specifically we have to take p and x? Anything we can take. Our aim is we have to find the value of p and q, and which is easy to integrate. Before the problem, it is very easy. We got the last two terms, very easy terms. Quickly we solved it. So the aim, whatever we are doing, the assumptions towards that easy integration it should be. So after multiplying p and x up and down, what we are going to do, the numerator completely we are adding. So p dx plus x dp. Here also we are adding completely. After adding, in the denominator, these two terms are getting cancelled. Whereas the numerator part, we can write it the UV, the formula, the differentiation of xp. That is, it's nothing but x dp plus p dx. So in a short form, we can write d of xp. We are expanding means we are getting this is the result. We can cross check it. This down is 2x zp. So the first and third member we have taken, one result we obtained. Next, second and fifth term member we are taking. That is, this is second member, this is fifth member. Now what we are going to do, the second member up and down we are going to multiply by q, whereas our fifth member up and down by y. So we multiplied q, here q is there. After multiplying we got it q dy divided by pqxy equal to, here the fifth member y dq minus pqxy plus 2z yq. So this is the result, we got it. Now the numerator we will add. After adding, we got it q dy plus y dq. This we can express as d of yq. We will do the differentiation, that is y dq plus q. Y differentiation is here y dq plus q dy. That's what here it is there. So we can write it simply d of, that is the first derivative of yq, divided by this getting cancelled. The remaining one is 2yzq. So the first result, this we obtained, taking the first and third member, this result we obtained. Taking the second and fifth member, this result we obtained. Here x and p assumption we have taken, multiply, that is up and down multiplied by p and up and down multiplied by x, whereas here up and down multiplied by y and up and down multiplied by q. Integrating. So both the sides we are going to do the integration. These are all the assumptions we did. P, x, suddenly we introduced y and q we introduced. The main aim, we want very easy integration. Now the integration is very easy. That is xp, the numerator up, the differentiation is there. Then we know the formula. We can put it that integration. Log of that term can be expressed. So log of xp. Here also yq, the up, the differentiation is there. So we can express log of yq plus log b square, the constant. Anything we can add the constant log b square. So log of xp plus equal to log of yq plus log b square we obtained. This we can logarithmic formula log a plus log b. We can write log of ab. So this and this both we put it log of y cube b square, which is equal to left side our log of xp. Log cancelled. We got it. Xp equal to b square y cube. This we named it as equation 2. Solving equations 1 and 2, and we are going to find the value of p and q. So this is our first, the given equation. Now in the equation, what we obtained, our equation 2, xp, where it is, we will substitute our b square y cube. So here is there our px. So that place we substituted our b square y cube. The balance qy is written as it is. So z square minus b square, this multiplication y square q square equal to 0. So z square equal to, just we are bringing towards our right side. So z square equal to b square y square q square. Therefore, q square equal to z square by b square y square, from which we can obtain what is q. So z by by. That is one of the reason. See, now the format, it's very easy to find the value of q. Here one doubt also will occur in our mind, which is going on ringing now. That is that before the first problem, we added the constant c1 and c2. We didn't add c1 square and c2 square. Whereas here we added the constant b square. Nothing wrong in it. In this problem also we can add the constant c1, but little make to comfortable to our problem some easy format. For that purpose, now q square equal to every term which is in the formation of square. That is the reason b square we added. If we add c1, that is also correct. So the q value we obtained. Substituting the value of q in equation 1, that is z square minus pxy, that is our first question. Here we are going to add what is q. So this place we added, that is z by by, our yy getting cancelled. So z square minus x pzx divided by b equal to 0. In this both z is common. So z of z minus px by b, the z we are bringing here, completely it is vanished. So the balance is z minus px by p, from which we can obtain minus px equal to minus zp, p equal to zp by x, that we are pushing towards this side. So we obtained what is p, what is q. So we are going to substitute these values in dz equal to p dx plus q dy. After substitution, we will do both the sides integration. That is, integral dz equal to integral of, we got the value p, that is zb by x dx, integral z by by dy. So here the integration is there. Now here z is there, here also z is there. Just we are bringing towards the left. So dz by z. Here the b we have just placed it front of the integral. So dx by x plus 1 by b dy by y. Here the completely the left side, the integration is log z equal to b log x plus 1 by b. This integration is log y plus the constant we added in terms of log, that is log a. Here log a, that is m log a, if it is there we can write log of a power m. Using this formula, just the first term we can write it log x power b. So this completely the logarithmic formula log a plus log b plus log c. We can write log of a, b, c. Similar way ours is, this is x power b, and this also we can write it y power 1 by b. It is written, this is a, equal to log z. Both the sides log, it is getting cancelled. Finally, we got it z equal to a into x power b y power 1 by b, which is the required complete solution. Now, we will move to the third problem, that is pxy plus pq plus qy equal to yz. The solution is our function let f of which has the variables, the function f which is defined in terms of x, y, z, p and q. The question is pxy plus pq plus qy minus yz equal to 0, that we named it as 1. Now dou f by dou p. So in this our equation we are searching where is p. Here it is there p. So the differentiation is 1 partially 1 into xy, and completely throughout the searching p, here also p is there. So the p, the differentiation is 1 into q. Same way, dou f by dou q. So in this, here q is there, q differentiation is 1. So 1 into p, and here is their q. The q differentiation is 1 into y. So the next one is dou f by dou z. Here the only one term, the variable z is there. Z differentiation is 1 into minus y. The next one is dou f by dou x. Here the term pxy is there, in which what we are going to do, partially the variable x is there. X differentiation is 1 into py. The next one is dou f by dou y. So here is there. Here it is there. Here also it is there. So dou f by dou y, that is here y differentiation is 1. So we are getting px. Here the y differentiation is 1 into q. It should be written here plus q. And here the y differentiation is 1 into z. It is not written here. Yes, now we obtained, that is dou f by dou y. We searched in the equation where y it is there. So here the term here y for the variable it is there, that is 1. So 1 into px, and here also y it is there. So 1 into q, and here y it is there, that is 1 into z minus z. So these all the values we have to substitute in the Charpit formula. So this is the result. Here we got it dou f by dou p, dou f by dou q, and dou f by dou z, and dou f by dou x. Whereas dou f by dou y, it's nothing but here plus q and minus z to be added. So the substitution we will concentrate now, that is dx by minus dou f by dou p, that is what I am circling, that is substituted in the particular places. So that is dou f by dou p, it's nothing but xy plus q, equal to dy by minus dou f by dou q, that is we substituted what I am circling, that is p plus y in this particular place. So the next one is here minus p, it is written, of dou f by dou p, this circled one which is written here, that is the third member, minus q as it is, of dou f by dou q, it is written p plus q. So the third member is completed, and the fourth member is dp by py, that is dou f by dou x, that is our py, plus p of dou f by dou z, that is our minus y. The last member is dq by dou f by dou y, that is px here also, plus q minus z to be added, plus q into dou f by dou z, that is minus pi. So all the 5 members we got it, but we are noticing we have to do the integration. Any assumptions we can take, multiply and divide any variable, but the integration should be very, very convenient and easier one. We are noticing the fourth member. The fourth member is dp by py minus py, it is there. That is this fourth member, dp by py minus py, it is there. This if we add, we are getting dp by 0. So dp by 0 means dp equal to 0. Easy to do integration. So that we are picking. Here some changes should be there, the last member. Here that should be added, plus q minus z. We are concentrating the fourth member only. So that taking the fourth member, dp equal to 0, integrating both the sides, here and here, p equal to constant. So p we got it, so some value, some constant, that we are going to substitute in our equation 1. So this is our given question. Wherever before substituting, some simplifications we are doing, that is what I am circling. In these two, y we are taking as common, then y of px minus z, the circled terms are becoming. Leftover is here, in these two, what I underlined it, q is common, so q of p plus y, which is equal to 0. So we can write q of p plus y equal to minus y of px minus z. So now q equal to, we can write it, that is here minus y of, just some simplifications we are doing, again minus we are bringing out, then it is becoming plus z minus px divided by p plus y. That's what here it is there. So the q equal to y of z minus ax by a plus y. Substituting these values in, d is equal to p dx plus q dy. That is, d is equal to, our p is a dx plus our q is just now what we obtained, that is y of z minus ax by a plus y into dy. Now, before that, any simplifications we can say it, this z minus ax, that is otherwise completely throughout left and right, we are going to divide by z minus ax. Then the left side is dz by z minus ax. Right hand side, the first term is a dx by z minus ax, plus in the second term already numerator z minus ax is there, divided by z minus ax. This both they are getting cancelled, plus y by a plus y into dy. The next one, this term, the circled one, we are pushing to left side. Then dz minus a dx, the numerator. The denominator is common, z minus ax, which is equal to, here there is no change at all, y divided by a plus y dy. Now we are going to do integration on both the sides. That is, integrating dz minus a dx by z minus ax equal to this y by a plus y. In a simplified form, we have written 1 minus a by a plus y. Whether it is correct or not, we can recheck it is also. So if you are doing the cross multiplication, a plus y minus a by a plus y, a cancelled, the previous step we got it. Now we did the integration, that is, here the denominator z minus ax is there. The differentiation, it is there in the numerator. Then we can write it log of. So z differentiation is dz, a, x differentiation is dx. So we can write log of z minus ax, which is equal to 1 into dy y minus a into dy by a plus y. We can write log of a plus y plus constant we added in terms of log. So log of z minus ax, this we brought it to the left side. It has become positive, plus a log of a plus y equal to, this as it is in the right side only, there is no change at all, y plus log b. So log of this, we brought it the logarithmic formula, that is a log, if it is there m, it is there, we can write log m power a. The similar manner, this a we have put it here, and here log a log b we can write it product log of AB. So this under product we wrote it. This is also can be written log, we can write this is log EB we can write. That is the constant. Anything we can add. This y can be written as log e to the base e. It's nothing but the value is 1. Log e, e. The value is 1. So we can write it y. So now here log of, here also log of. This is also under product we wrote it. Log A plus log B, we can write it log AB. Here log E. Here the circled one, we put it e power y into b. Then both the sides, we are cancelling the log. Then z minus ax into a plus y power a equal to b into e power y, which is the required solution for this. And if you want here also, because here we added that is the y value purpose, y it's nothing but log e. That concept of purpose we added. These are the simplifications purpose. Otherwise, before step itself also we can stop. The next problem is solve z equal to p square x plus q square y. Now, the solution is our function f, which has the question we are saying, the variables which are dominating. X is there, y is there, z is there, along with p and q is there. So, f, the function of x, y, z, p, q, we named it as equation 1. Dou f by dou p. In our equation, I'm circling, there p is there, p square is there, p square, the differentiation is 2p into x is treated as constant 2px. Next, dou f by dou q. So here q square is there, q square differentiation is 2q. 2q into y. Dou f by dou z. Here the differentiation is 1. 1 into minus, minus 1. Dou f by dou x. Here only one term, x is there. X differentiation is 1. 1 into p square, p square. Dou f by dou y. Here the term y is there. Y, the differentiation is 1. 1 into q square, q square. So what are the terms are required to substitute in the Charpit formula we obtained? So the Charpit's auxiliary equations are, so dxy minus dou f by dou p equal to dy by minus dou f by dou q, which is nothing but our third member dz by minus p dou f by dou p minus q dou f by dou q equal to the fourth member in terms of p dp divided by dou f by dou x plus p dou f by dou z equal to dq, that is our last member, dq divided by dou f by dou y plus q dou f by dou z. So in this Charpit formula, what are the results we obtained? We are going to substitute. So these are the values we obtained. We are going to substitute. That is dou f by dou p. Here we are going to replace 2px. Dou f by dou q, in the place we are going to replace 2qy, and minus p. Here also we are going to replace 2px minus q dou f by dou q. Again we are going to replace 2qy equal to dp divided by dou f by dou x. We are going to replace p square plus p dou f by dou z. We are going to replace minus 1. The last member dq divided by dou f by dou y, that is q square plus q dou f by dou z, which is replaced by minus 1. So all the values we substituted. So after substituting, we got it dx by minus 2px dy by minus 2qy equal to our third member dz equal to minus 2, that is we have taken common out after substituting p square x plus q square y, which is equal to the fourth member dp by p square minus p equal to the last member, that is a fifth member dq by q square minus q. Now among these five members, any assumption or any two members which is easy to integrate, we have to select. So the five members are ready. Now we are going to take the first and fourth member, first member, fourth member. So we are going to the first member, multiply and divide by p square. So we multiplied here p square into dx, p square dx. The down minus 2px is there into p square. We got it minus 2pqx. And the fourth member we multiplied by 2px. So 2px dp. Here also the denominator p square into 2px. So 2p cube x minus p into 2px, 2p square x. Now just we are adding the numerator put together. So it has become, these both are added, same as it is the denominator also we are adding. So we got it p square dx plus 2px dp divided by minus 2p cube x plus 2p cube x minus 2p square x. That is here a minus 2 plus 2, both are getting cancelled. The leftover, the term in the denominator is minus 2p square x, whereas the numerator p square dx plus 2px dp. So now here that is written actually the simplified, that is the last step of the previous slide. Now we can put in the numerator in such a way, that is the differentiation of p square x we can write, that is p square, x differentiation is dx, x, this differentiation is 2p dp. That's what here it is there. So in a short form we can put it, the derivative, the differentiation of p square x, this is written in such a way mathematically we can write. So denominator is minus 2p square x. Such a way now first and fourth, that is first and fourth we have taken, we obtained this result. Next second and fifth we are going to take. This is our second member. Here the fifth member. The second member we are going to multiply numerator and denominator by q square. So we multiplied q square into dy, q square dy, minus 2qy into q square, we got it, minus 2q cube y equal to this member dq by q square minus q, that is multiplied by 2qy, that is numerator and denominator we have to multiply. So 2qy dq divided by q square into 2qy, it's nothing but 2q cube y minus q into 2qy, it's nothing but 2q square y. So completely the numerator and denominator we are going to add the terms. So after adding the numerator, there is no change. That is, no terms are getting cancelled. Whereas in the denominator, these terms are getting cancelled because minus 2q cube y plus 2q cube y. They are in opposite signs. They are getting cancelled. After cancelling, we got it here. The numerator, in such a format we can put it d of q square y. We can expand it, this differentiation, that is q square, y differentiation is dy, and y, q square differentiation is 2q dy. So the previous step we got it, divided by minus 2q square y. So already this we simplified, we got it. Just now we simplified this term, we got it. Both the sides, this minus 2 common, they are getting cancelled. The leftover is differentiation of p square x by p square x. So noticing this we are very comfortable for our integration because p square x, the differentiation is up, it is there. Here also q square y, the differentiation is up, easy integration. To obtain this easy integration purpose only, the multiply and divide, the terms are taken. It's not any imaginations and all. To get the easy integration purpose, any terms we can take, but integration should not be complicated. Very easy way it should be. So integrating now on both sides. So the integration of d of p square x by p square x equal to integration d of q square y by q square y. So the p square x, the differentiation is up. Q square y, the differentiation is up. So we can write log of p square x equal to log of q square y plus constant. In terms of log, we added log a. So log of p square x, which is equal to, this is log a plus log b equal to log of ab. That logarithmic formula we followed here. So log of a into q square y, it is written under product, and both the sides log are there, they are getting cancelled. So the leftover is p square x equal to a into q square y. This we named it as equation 2. Now solving the equations 1 and 2, and we are going to obtain the value of p and q. So this is our equation. We are substituting, that is what we obtained now, p square x equal to this value we obtained. So in this p square x place, we substituted a q square y plus q square y, which is equal to z. We didn't touch as it is. And in these two terms, q square y is common. It has taken out. So q square y of the leftover is a. It is written here. The second term, it has completely come out. So the leftover is plus 1 equal to z. So q square equal to z by y of a plus 1, from which we obtained what is q. So q square equal to z by y of a plus 1, then q equal to square root of z by y of a plus 1. Now we are going to substitute the value of q in equation 2. Our equation 2 is p square x equal to a q square y. So p square x equal to a into what we obtained, our q square is, that is q equal to square root of z by y of a plus 1. So q square is z by y of a plus 1. That is, in this place we substituted, that is a q value, and the y is written as it is. So now this y getting cancelled. We got it, p square x equal to a z by a plus 1. Next, p square equal to x we are bringing here. Then a z by x of a plus 1. Then p equal to square root of a z by x of a plus 1. That is, p square equal to this, p equal to square root of this. We got it. What is p? What is q? We are going to substitute these p and q values in dz equal to p dx plus q dy. That is, dz equal to square root of a z by x of a plus 1. What I am circling, that is the value of p into dx plus q value, what I circled, that is square root of z by y of a plus 1 into dy. So this is only we obtained, just now we discussed. So now we are going to push whatever the z terms and all one side. So we are noticing here z is there, here is there, that is a square root z is there, that we push it to the left side. And here also a plus 1 is common, root a plus 1, that is also we push to left side. So z divided by a plus 1 we push to left side. The leftover is here a and x. That's what here is the root a, root x. Here also y is there leftover and dy it is written. We have to do the integration on both the sides. So both the sides to do the integration. So square root of a plus 1, that is a constant, dz by root z equal to root a divided by dx by root x plus dy divided by root y. So the integration is very simple one, that is dz by root z. That root z we can write it top bringing z power minus 1 by 2 dz. We know the integration, the formula z power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 equal to z power 1 by 2 divided by 1 by 2 equal to 2 of root z, 2 into root z. That's what here it is written. here it should be root z should be there. Root z should be there, equal to root a. Similarly, dx by root x, it's nothing but 2 into root x plus dy by root y, that the integration is 2 root y. In terms of just now we did a root z, similar way, that is a integration of dy by root y is 2 into root y plus b. Constant we added as b. So the next one is here root z should come, that integration. So throughout, if you're noticing, 2 is common, here cutting, here. So that is b is becoming divided by 2. So we obtained root z of root of a plus 1 equal to square root of ax plus root y plus b by 2, which is the required solution. So we will come to the conclusion of this Charpit's method. That is the Charpit method, which is used to find the complete integral of nonlinear differential equations, for which first we have taken px plus qy equal to pq. What are the terms are required to substitute in Charpit formula? First, we found it. Afterwards, we did the substitution. After substituting, our aim is to find the value of p and q. After finding the p and q, z equal to p dx plus q dy, and we did the integration both the sides, and which is the required solution for our given equation. These are the steps which are followed. 4 problems we have taken. The first one, px plus qy equal to pq, z square equal to pqxy, pxy plus pq plus qy equal to yz, z equal to p square x plus q square y. The different 4 problems we have taken and we discussed it. Thank you very much to all.
Like, share and subscribe. Hit the bell icon for more updates.